Hello friends, welcome to Easy Learn. In this video of Standard 8th Maths, we are going to study Chapter 4, Altitudes and Medians of a Triangle, Practice Set 4.1. If you like the video, do subscribe it and press the bell icon for the notifications. What is an altitude of a triangle? If, suppose this is a triangle, the perpendicular segment drawn from the vertex of a triangle on the side opposite to it is called an altitude of a triangle. Now in this figure, ABC triangle, suppose A is the vertex. So from the vertex A, we have to draw a perpendicular line to its opposite side, that is BC. So the perpendicular is AP. Therefore, in triangle ABC, seg AP is an altitude on the base BC. Remember, a triangle has three altitudes. Why? Because it has three vertices. Therefore, from each vertex, if you draw a perpendicular, you get three vertices. And all the three altitudes are concurrent. Now, concurrent means it is the point where all the three altitudes meet each other. So, if you see here, this point is your point of concurrence. The point of concurrence is called the orthocenter. So, this point here, O, is called your orthocenter, and it is denoted by the letter O. So when the altitudes meet, the center point is called as orthocenter. So in this case, segment XR, segment YQ, and segment ZP are the three altitudes of the triangle XYZ. The location of the orthocenter. The altitudes of a triangle pass through exactly one point. That means they are concurrent. The orthocenter of a right angle triangle is the vertex of the right angle. The orthocenter of an obtuse angle triangle is in the exterior of the triangle. The orthocenter of an acute angle triangle is in the interior of the triangle. Now all these three types of constructions we are going to see in our next video, and the link will be shared in the description box. What is the median of a triangle? The segment joining the vertex and the midpoint of the opposite side is called the median of a triangle. So if you see the triangle HFC, in this triangle we are taking the first vertex as F, and from the F we are drawing a line segment that joins HC exactly at the midpoint. Midpoint means center, which divides into both equal parts. So in this diagram or in this triangle, F is the vertex and D is the midpoint of the opposite side HC. Therefore we can say that in triangle HCF, seg FD is the median on the opposite side HC. Remember, again, a triangle has three vertices, therefore it will again have three medians. And again here all the three medians are concurrent. If you see here, they are meeting at one particular point. The point of concurrence is called centroid. So this point is called the centroid, and it is denoted by the letter G. Therefore in the figure, sec PC, sec QA and sec BR are the medians of triangle ABC. Now what is the location of a centroid of a triangle? For all the types of triangles, the location of G, that is centroid, is in the interior of the triangles. The centroid divides each median in the ratio 2:1, very important, because it is at the midpoint. Comparison of altitude and median. Now, it's just a small comparison between what is an altitude and what is a median. Altitude is a segment from the vertex perpendicular to the opposite side, whereas median is a segment from the vertex joining the midpoint of the opposite side. The point of concurrence in altitude is called orthocenter. The point of concurrence in median is called centroid. Orthocenter is denoted by O, centroid is denoted by G. The location of orthocenter is different for different triangles, and the location of centroid is always at the interior of the triangle. So this is a diagram for altitude and this is a diagram for median. A small comparison. Practice at 4.1. Question number 1. In triangle LMN, dash is an altitude and dash is a median. Write the names of the appropriate segments. Now we know altitude is something which is perpendicular and median which is something which divides the midpoint. So in this case the perpendicular is LX. Therefore, in triangle LMN, seg LX is an altitude and seg LY is a median. Fill in the blanks. In this following diagram, triangle ABC, point G is the centroid. If G is the centroid means all are medians. If RG is 2.5, if this RG is 2.5, then we have to find how much is GC. Second, if BG is 6, how much is BQ, this entire BQ that we have to find. Now first, let us go with the first one. We know that the centroid divides each median in the ratio 2:1. Therefore, for the first one, length CG upon length GR is equal to 2/1. Now, out of this, GR is given 2.5, so length GC upon 2.5 is equal to 2/1. Therefore, length GC is equal to 2 multiplied by 2.5. That is, length GC is equal to 5. So, therefore, in this case, you have got this length GC as 5, which is exactly double. Second one, length BG upon length GQ is equal to 2/1. Now BG is given as 6, GQ you don't know, that you have to find GQ. Therefore GQ is equal to 6/2, that is GQ is equal to 3. So here you got this GQ as 3. But in the question they have asked BQ. Now what is BQ? BQ is nothing but BG plus GQ. So length BQ is equal to length BG plus length GQ. BG is 6, GQ is 3. So therefore length BQ is 9. Third, if length AP is 6, now if this full length AP, if it is 6, we have to find length AG, this and this GP. Both we have to find. So we know that the centroid divides the each median in the ratio 2:1. So length AG upon length GP is equal to 2:1. We can also say that length AG is equal to 2 times of GP. We are shifting the GP. Now suppose GP is X. Let us assume GP as X. So length AG will be 2 times X. Now length AP is equal to length AG plus length GP. So let us substitute the values. So length AG is 2 from this and length GP is X from this. So we get 6 is equal to 2x plus x. That is 6 is equal to 3x. Therefore x is equal to 6/3. That is x is equal to 2. But now what is x? We have seen here x is what? X is GP. Therefore length GP is equal to 2. What is AG? AG is 2x. That is 2 into 2. That is AG is 4. Thank you.